All right, so one of the things that you have been seeing for the past 2 days in terms of using generative AI, beyond, for example, the use of LLMs, large language models, like ChatGPT, for example, or Google Bard, or others like Facebook Llama model, is the use of generative AI to, for example, produce images. What you see here, for example, is a Stable Diffusion from Stability AI. They developed this model that is comparable to, for example, DALL-E or the famous Midjourney, in which, in this case, it works in a very similar way. So, for example, you can input, as you saw, for example, from other examples, picture of a coffee mug made of titanium on top of a table. For example, you can do something like this, press enter. In this case, what I'm using is clipdrop.co. It's the website from Stability AI when you can generate different images. And you can see that you can get a fairly nice image, actually a very nice image, using this model that is Stable Diffusion XL. But there are a couple of things that we can do better. So, for example, if we are designers, if we are using 3D modeling, if our everyday job, for example, has to do with generating 3D content, and there are some stages, for example, in the design process when you need to quickly iterate, quickly think about what could be, for example, the materiality, the color finish, the appearance of a product that I am designing. There are several ways on how to, for example, use generative AI to expedite the process. In this case, what we see is very good for inspiration. It's very good, for example, to start putting this in a mood board, or, for example, to get reference images for 3D modeling. The thing is that how can we control, for example, or how can we pair the power of generative AI with the power of, for example, 3D modeling? If you, for example, happen to use 3D model tools, you will see that, or you will find that most of popular 3D modeling tools, for example, here I'm showing you Blender, and we have something that it's a coffee mug or a liquid container, right? A 3D model, and usually the way that you will iterate about color finishes is just like generating, for example, new materials. For example, a material that is like a glass material, so you make it reflective, or you will make something that is more on the side of translucent materials, or, for example, like glossy materials. Let me change this. You can change, of course, the color, and so on and so forth, right? And you can, of course, modify this, controlling the vertices, controlling faces, and so on and so forth. This is very common to a lot of software. So, for example, we have a similar exercise here in a more let's say traditional CAD software, not necessarily like a VFX or general 3D modeling process such as Blender. So, for example, this is something that will resemble more like product design, or is a more product design oriented 3D package, when you can do similar things, right? Check the appearance, change the background, change a couple of parameters, but there is something missing, right? And what I mean by that is how, for example, will you get the same or similar quality of what you're seeing here in a fast way, and also in a few steps taking advantage of generative AI. So, for example, this is, and when we talk about 3D generation, right, we have powerful software. I'm going to show you an example here in Rhinoceros. That is a very powerful 3D modeler, parametric modeler, where you can just like, for example, SolidWorks, NX, and other software, you can define parameters to define a shape. In this case, I'm defining, for example, different parameters to control or to work on the generation of what could be, in this case, a container. So you can see that sometimes some parameters work better than others, but here it allows me to generate some variations of what I've been showing you. So for example, let's say that this is what I want. So how can I use, right, again, from a very simple way, from a very simple, let's say, screenshot or from a very simple model, how can I pair this with generative AI to generate excellent results and to actually engage in an exploration, right? To get a catalog, for example, of materials, to get to, for example, change with the lighting, or play with the lighting, play with the background. So what I'm going to show you is exactly that in this short exercise. So let's imagine that this is our model. In this case, what I'm going to do, I will generate a view, for example, like this. I will quickly set an appearance. So for example, let's say I like this shape. So I can generate a 3D model, right? I can, so let's say that this is a 3D model, and this is something that I would like to use for with a generative AI to generate like different views, different iterations, different images, right? So one thing that I will do, something very simple, let me just change a couple of parameters here. I can just adjust that I don't want to see, for example, a grid or axis, and so on and so forth. And I don't want to see, for example, sub-D wires. So let's say that this is a very clean image. I'm going to take a screenshot from this. And I will save it. And I will save it in, for example, in this disk. I will say like this is a screen capture. Let's say I'm going to do one from the side. I'm just going to grab two, just for the purpose of demonstration. So I will just get this and save it with a different name. So what we are going to use for this is Stable Diffusion, but not the version that I show you here, because in this case our only interaction with the generative AI model is based on text prompt. But what if we can control it? What if we can add another layer, right, of control to generative AI, right? If I'm for example, a designer, or if I'm someone that works with sketches, or if I'm someone that works with 3D modeling, I can quickly use, again, like text prompts, but also add this layer of control through the work that I'm developing in a 3D environment. So for that, we are going to use this is Stable Diffusion, and this is something that might look like an interface that is kind of complicated or maybe convoluted, but this is a local version that you can actually run on your computers that will give you more parameters to control and basically like more, again, possibilities of exploring the limits or the boundaries of generative AI when it comes to mixing it with, for example, 3D content generation. We will see here that we can use different models, right? Different models that have been trained or curated based on different content to make, like, for example, more realistic images versus like more comic-like or rendering images. We can control, for example, parameters like the resolution of the images that we are creating, also the amount of images that we can create. But one thing that is very, very interesting, we can explain later, for example, these parameters that have to do with how the image is sampled or the noise is sampled to generate an image. But here, for example, we have ControlNet. And ControlNet allows you to use different machine learning models to input an image that you produce. So I will go to, for example, this folder, and I will get this image. I will position this image here, and I can enable this, and I can do a couple of things like, with a model, try to turn this into a sketch model, right? And I will use this outline that is generated from an image to drive the generation of another image based on a prompt. So for example, I can use this, I can use, you see, I can generate this image that will be used by Stable Diffusion, in this case the generative AI model, to create something that resembles this image. So let's try, for example, let's just start trying something. So we can use actually the same prompt that we used before. If we can edit it, yes, here for example, a picture of a coffee mug made out of titanium on top of a table. Another thing that is interesting with Stable Diffusion is that you can provide negative prompts. For example, things that you don't want in your image. But we can play with that later. So let's say we will generate this image. We will just resize the image that we have here, and we will set the resolution to, for example, 768 on the, no, sorry, it's the other way around. With 768 pixels by 512. So if we hit generate, Stable Diffusion, as you will see here, it will load what is called the weights, that is the trained parameters of the model, and it will start generating first what I'm doing here with ControlNet, that is a sketch or an outline of the original image, and then you will see that this starts producing an actual version of what we see here. And this is super interesting, right? I think, yeah, I messed up with the parameters. So this is generating an image that is probably like, it's a stretch, so it's not exactly what I want. But what is interesting here is that you can get like very quick results, very good iterations, and very good quality images. Basically things that you will get from Stable Diffusion, the website that is very limited, and it's a where you have less control, just with a few clicks. You saw here that I just loaded the model, I just put the prompt, I just put a couple of parameters, and then I was able to generate very interesting images from it. So for example here, if I open the images, yeah, they are like stretched because I didn't change one parameter, but you can see that we are getting results that these are actually very similar to our input image, and they are made out of actually like a metal, and they are on top of a table. So let's try changing a couple of parameters, but also adding a couple of more things. So let's say canvas width, let's say this is width. Oh, let me change this to 7, 8, just resize, and yeah. So for example, if you want images with better quality, you can play with parameters, for example, how many sampling steps you want. These models, the way that they work, and probably you saw it in previous presentations, they work by generating just noise, a noisy image, right? And then, let's say, organizing the pixels to resemble, or that basically will fit the description of a text prompt. So the more sampling steps, the better is the resolution. So let's say, let's change a couple of things here. A picture of a coffee mug made out of titanium on top of a table. We are okay with that, but let's say we want to add another layer of control to this. One layer of control, for example, will be like, okay, you will take the image, you will do something that is generated according to these outlines. But also, let's say if you want to generate like better shadows or more depth in the image, you can use another model on top of that, another machine learning model. So we will provide the same input image. We will drag it here. We will enable it. And we will, in this case, say, okay, now you will use, for example, depth estimation. And depth estimation is a technique used with machine learning where basically you can extract grayscale values to determine how deep an image is. So with that, you can, of course, apply blurring effect, for example, or use it to mimic things like bokeh in a picture and so on and so forth. So in this case, I'm just going to do exactly what I did before. I will change the resolution and I will press to generate an image. In this case, I will generate just one image. So I will put the batch count to 1. I will generate this and hopefully we will see the image generating. So you see that now is this is the command line where it's saying that it's loading the models to process the different aspects of the image. So in this case, you will see the preview of the image that is being generated, and it's using both machine learning models to generate an output. So if I go here, for example, this is the image that I just created. Now this is not stretch. You can see that at some point, like shadows and other things are working very well. One thing that it didn't do though is the wood table part, but we can fix that later. So again, this is very powerful. So let's do something different. We have seen that we can create, again, the different images. We can specify, for example, instead of titanium, for example, the picture of a coffee mug made out of wood on top of wood table. So if I press generate, again, the software here will take the image, will pre-process the lines, the sketch lines. It will pre-process the depth estimation that I can show you, and then it will try to generate an image. So in this case, again, the appearance will vary according to the model that we're using. So if I go here, and if I go to not this, if I go to open, for example, the image, now the image you see is a wood coffee mug, or a wooden coffee mug. So let's say we want to explore materiality in a more automated way, right? So let's say we are going to have some lunch, so I will just let the computer doing some magic or some let's say iterations. Stable Diffusion gives you another layer of control that is based on scripts where you can explore different things. So one thing that I like to explore always, for example, is this idea of prompt SR that allows you to, for example, if our main materiality, for example, here, let's erase the second wood, a picture of a coffee mug made of wood. So we know that our first keyword to explore materiality is wood. We can just comma separate wood and write ceramic, titanium, glass, concrete, steel, red, green, etc. So what is going to happen here is that the Stable Diffusion will generate several images by replacing wood by ceramic, titanium, glass, concrete, steel, red, and green. And that is actually quite powerful. So another thing that will be, let's say, on top of a table, studio lighting, studio lighting, right? So let's say we want to not only explore material properties, but also appearance of the light of the image that we're generating. So if we copy here, like studio, and here, for example, on Y, we said also prompt SR, and we do a similar thing, studio, indoor, outdoor, nighttime, daylight, night, day, light, I don't know, like golden hour. Okay, let's say this. So we will, in this case, generate a matrix of images, where basically it will generate first a wood version of the mug, but with studio lighting, indoor lighting, outdoor lighting, night, daylight, and golden hour. Then it will generate a ceramic mug with, again, all of those types. So you can start like mixing and playing with prompt, and also playing with the images that you put here. So we're going to do something different. We're going to use, no, actually let's use the same image. And let's see what we get. So we will leave, for time purposes, our sampling steps to 20. We will change the sampler, and we will just generate images. Let's see what happens. So we will see that some images will start appearing here. So again, first thing, you will see the model loading the scripts. It will generate, in this case, 48 images in a grid that is 8 by 6. So it's generating the images now. So you see that it generated the first one. This is with studio lighting. It's a little bit noisy because I didn't provide too many samples. So you will see how, again, images start popping up. And again, this is very powerful because it allows you to not only automate the process of generating different options for what we're exploring, in this case material appearance and also light appearance, but it relieves the setting of, again, like different lights, for example, in a 3D software, and different materials, things that are actually time consuming. So this is actually a pretty practical example on how to use generative AI to expedite the process of, for example, material exploration inside a digital environment. So let's see a couple of samples more. So again, I'm generating a bunch of images just by changing those parameters. Actually, let me just delete the first one because they were not very happy in terms of results. So here we see just a quick exploration without setting materials, just setting text prompts. And also you can see that now we are back to the exploration based on light, right? So in this case we're with a different light. So in this case the second prompt will be indoor light versus the other one. So they are kind of like similar. Probably we need to fine-tune a couple of parameters, but you can see that we're getting, again, like a good material palette. And what I like is that you can simulate like interesting things, for example, like the color bleeding based on material qualities and so on and so forth. For example, in this case, it did a very, very good job on simulating like physical properties of something that basically doesn't exist. It's not a 3D thing. So as goes, so for example here, this is generating also like different shadows based on, for example, like outdoor lighting on top of the materials. In some cases it's doing it, in some cases it's not doing it. In this case, like the background is kind of tricky because we're the information that we're using to generate this is this. So we are controlling also how Stable Diffusion will consider, in this case, the depth of the model, but at the same time is considering the basically we don't have any background, so we can fix that. So actually, let's do that. Let's just go back, for example, in whatever software that you use. We can generate something like a plate, like a dish, for example, for this. So I'm just going to generate a planar surface. So this gives a little bit more of context. Let's put this as another planar surface. So we can do something like this, extrude it a little bit, and at the same time extrude this a little bit, so we can get more information to give to Stable Diffusion. So getting rid of the curves. So let's generate another view. For example, is from this side. I will do the same thing that I did before. It's just generating a screen capture. We will save it with the same name, and we will put it inside Stable Diffusion. So inside Stable Diffusion, we can again go to our image, drag it here, because we will be using this to guide the generation of images. We will use again this depth estimation model. So if you're wondering what this is doing, this is generating this type of image. And we can use another one actually that is called, for example, normal map. And normal map, if we use it with the same image, also helps a lot in the generation of better like surface quality. So let's preview what I'm doing here. So you see that it estimates more or less from the image like a normal. We can always increase the resolution of the normal. We can, for example, decrease the background threshold. It will take a little bit longer. We can use this. So it will do probably something that is very noisy here, but I just wanted to show you that this is possible. So let's do something pretty similar to what we did before. Wood, ceramic, titanium, glass, studio, indoor. So actually let's decrease the number of like light parameters, the second prompt. But other thing that I wanted to show you is that when you go to Stable Diffusion, the website, clip drop, for example at Midjourney, usually you need to specify the style that you're doing, right? So for example, this is like photorealistic, this is like anime, some things will look more like, I don't know, like fantasy or CGI rendering, fantasy stuff. The good thing about Stable Diffusion is that you have a lot of models that you can download that again have been trained on different data sets, right? Style images or artist images. So we can use that to also generate variations. So for example, here we can say that we will introduce a third axis to our prompt generation. We will have, for example, one model that is called OpenJourney. That OpenJourney was trained on Midjourney images, so it will generate pretty similar images to what Midjourney is doing. Protogen that has like a specific, more like fantasy-like or dream-like photoreal that is like, again, like very photorealistic images, but with some component of like, again, like refined or edited photography, or Impunk diffusion that is a model that generates more like comic-like sketch images. So let's see what happens. So in this case, we're using 3 control net models to derive the generation of our image. So you will see that we have a very delimited like set of lines for the dish, for what we are indicating that could be a table. So let's generate a couple of images and let's see the results. So if we go to our folder, so we see that we're getting some other type of images. We see that we're getting some more detailed information, but at the same time we're getting like things that we can tune. We now see that this is a surface. We're getting this this dish. Again, as an exploration, is quite interesting. So you see here the same thing is doing more or less like a pretty good job in exploring with the different models. So again, for now we're using this OpenJourney that is using a model that was trained on Midjourney images. So it will generate images that, yeah, like the ones that you will get from actually using Midjourney. So let's wait until we generate from the other model as well. So we can see how we get like many iterations. Again, these are the first explorations, but then based on our second image, we see that based on our prompt, we can get like different types of lights, but all, at the same time, different types of material qualities, and also we can use different models to generate different results, right? One more thing that I want to show you, for example, is that in this case, like let's say you're designing something and you're not necessarily someone that knows how to use 3D modeling. So I will show you a way that you can also use your own sketch. So let's say you're using your own, let's say like an application, or you can just scan your own sketches. So for example, here, as you can see, I am using a tablet to draw something. It's not a very good drawing. That is fine, but you can refine it. You can just generate I don't know, like some features that you want to include in the image. So if we go back to Stable Diffusion and we go to ControlNet and we input that image, that is the one that I have here, I can just, let me disable the prompt matrix because we don't want the prompt matrix to be working for this example. So I can just again use the same prompt with this image now to generate another iteration. So we will see it here being generated. So it did it here. So also you can explore. I mean, I didn't give like much more detail, and it was not a very good image, but you can see that you have like with this type of tools that they of course are more complicated, but also they are more let's say powerful than just the ones that you can find online like Midjourney or Stable Diffusion, to generate or to iterate or to explore different alternatives from like different views to different materialities. So I hope this covers more or less what you're a brief demo of what you can do, pairing again the power of 3D data, 3D modeling with the generative AI to explore different things. So now we will do a practical exercise, and we want you to explore based on the assigned task that we gave you. So thank you very much.